Factoring you know already, or in theory you know. Types of factoring to know in Ma10. Okay, as in factoring polynomials, right? First kind of factoring of polynomials you learned was called GCF. We'll do one example of each thing here real quick. As in, if you have something like this, 12x squared plus 18x, let's make that to the third, x squared minus 6x. Greatest common factor kind of factoring is looking, do these things have anything in common? Do those things have anything in common? What do those have in common? Because they do have something in common. Do those have a common factor, all of those things? You can divide them all by 6. What else can you divide them all by? If you broke them all down, at first you were doing this by writing this as like 2 times 2 times 3 times x times x times x. We don't have to do that by the time we're good at this. But remember when we were doing that and you were kind of saying, well, they all have a 2 and a 3 in common and an x, right? They all have an x in common. We don't necessarily want to always be doing that. We want to move past writing that step. But if they have 6x in common, that's the greatest common factor. But you got to put the other factor, which is what polynomial would be left if you split it up into that. This polynomial can be written as 6x times what has to be left in here. What polynomial would have to be left in there? As in, what would you have to multiply it by to get the original one? Right? What question would give you this as an answer? What multiplying question? Look, one term at a time. It's going to be 3 terms in there, right? It's going to be this, this, this. What are each of those terms going to be? What's the first term got to be? It's got to be a 2. And do we need any x's? We need x squared, right? Because you got to have x to the third here. What about the second term? It's going to be plus. It's got to be 3. And we need another x, right? Because we got that left over. Again, if it helps, write it out the long way and then just highlight what's out in front and then whatever else is left, right? And what would the last term be? If you have a 6x in front and this is a minus 6x, you don't just close the bracket earlier. You still need a term there. It's going to be a minus 1, right? That's the first kind of factoring, which is, we're just going to call it factoring out the greatest common factor. Second kind of factoring we learned was trinomial factoring. Greatest common factor you can try on any polynomial that you're given. Greatest common factor was section 5.2 if you're looking for it in the textbook. Trinomial was 5.3. This is when you had special trinomials like 2x squared minus 3x minus 5. That kind of thing. Okay, if you had something x squared minus something x minus something. If it followed that pattern. If it was like, and you might see it written in the textbook, ax squared, so something x squared plus bx plus c. It has to be of that format. It has to be something x squared, something x, and then just a constant number. That wasn't a single term times a big, huge polynomial. That was instead this pattern of we tried to factor it like this, as in 2 brackets here. That's trinomial factoring. The kind of general strategy you look through is you said, let's look at that first and decide what the first things are. Because that comes from the first 2 terms. That term comes from the first term in each bracket. If that's 2x squared, there's only one way it could be. 2x and x. Then you look at the last term here. The last term comes from the last 2 terms. It comes from one place. So you think to yourself, what possibilities do I have for 5? I only have a couple, right? I only have one, basically. What pair of numbers can you think of for 5? 5 times 1. Since these are different, you got to try it a bunch of different ways. I'm going to put a 5 and a 1 here like this and check if this works. Now the fact that it's negative 5, I got to put a plus or a minus, so I'm just going to put in plus minus and see if that works. Does that work to get the right middle term? The middle term comes from the outside and the inside terms. I got plus 1x and I have minus 10x. Does that work? Definitely doesn't work. It doesn't give me minus 3x, that's for sure. It gives me minus 9x. What if I was to change this? Is that going to make it any different? If I switch the signs of that, all I'm going to get is that plus and this minus. That's not going to make any difference. I know it can't be 5. You can kind of ignore the signs until you decide which way it is. You can just say, that's 1x, that's 10x. There's no way to get a 3 out of that if I subtract. So you know it can't be that way. So what you need to do instead then is, that's got to be over here. That's got to be over here. That's the other thing to try. Since 1 is 2x and 1's x, you got to try both those ways. Is this going to work now? This is 5x. That's 2x. If one of these was positive and one was negative, can I get a 3 out of that? You can, right? Which one has to be the negative one? Which one of these two things? If I want a minus 3x, which one has to be the negative one? One of them's negative because the last term's negative. That's got to be the negative one, right? Which means that's got to be the minus, and that's got to be the plus. That was the process we went through for trying to factor trinomials, right? So the two factors are those two brackets. You have this single polynomial up here. I guess we could use a different color. That single polynomial breaks down into this factor and this factor, those two things. Third kind of factoring that we just, most recent one, well, it's kind of two, I guess. Section 5.4 is called special trinomials, but there's two things. There's difference of squares, and there's also perfect square trinomials. Perfect square trinomial just, it's not anything different. It's this, except that it happens that the two brackets are identical. It's not anything different. A difference of squares is something like x squared minus 121. X squared minus 121. This is as though, this is like that there was nothing in the middle. This is like the middle term was plus 0x. It's like there's no middle term. The middle term cancels out, so it's not even there. The two brackets have to be identical except for the sign. If it's x squared, it's got to be x and x. If the last term's minus 21, you got to have plus 11, minus 11. The middle term cancels out. That's the difference of squares. That single polynomial breaks down into this factor times that factor. And then the second part of that we talked about before here was perfect square trinomials. Again, something like 4x squared minus 12x plus 9. If this is a perfect square and this is a perfect square, you might think about whether this term is right to make it a perfect square trinomial. It's got to be double as much as whatever the square root of each of those are. So you could try it. You could just write one of the brackets down. You could say, what if this was 2x minus 3? Since this thing is twice as much as both of those, then this is going to be what it is, right? Or the short way to write that is 2x minus 3. It's not a different kind of factoring. It's just a trinomial where the two brackets happen to be the same. There was one thing that was factoring by grouping, but that's kind of not that big of a deal here. I wouldn't worry too much about factoring by grouping. Factoring by grouping was when you pull something out of, it was in 5.2, there was one example on factoring by grouping, but we can do one thing here. But it's not going to be a big part of Ma10, I think. Factoring by grouping we'll put in here. This is when you have something like x to the third minus minus 4x squared plus, gotta try and do this off the top of my head here, plus 3x, or minus 3x, plus 12. If you're factoring that by grouping, it basically just means look at the first part as a group. There's nothing in common throughout the whole thing. There's nothing in common throughout the whole thing. But each group, each pair might have something in common. What does that part in yellow there have in common? It has x squared in common. What would be left if you factored out x squared out of the first group? X minus 4. Okay. The second part, what does this have in common with each other? What do they both have? You got 3 and 12. They both can be divided by 3. I'm going to put a minus 3. If I factored out a minus 3 out of that, what would have to be in there? Minus 3 times what gives me minus 3x? What do I have to have at the beginning of that bracket? X, right? What about the second part? If I have minus 3 here, what has to be the second part of that bracket to get 12? If I got a minus 3 there, I need a minus 4 there. The only time this works, this factoring by grouping, is if the thing that you get is the same. It's like you're factoring out a binomial factor. This whole expression here, this is common. It's like you have two groups here. That's one group. That's the other group. Both of them have that x minus 4 in common. You can actually pull that out in front. What would you be left with if you pull this out? If you pull that common binomial out, so we put this in front, and we only write one of them. What do we got left if we pull out that? You have x squared minus 3, right? So you can factor that with that common binomial in front. You can write it as, I took out the x minus 4, and then what I got left is x squared minus 3. That's factoring by grouping. It's something that you might want to learn, but it's not going to be a big deal. Know the other ones for sure, okay? The other ones are more important. Are we okay with this? I hope. You need to be okay with all of those before you tackle the last section. The last section is just starting to do combinations of those things, trying one kind of factoring, and if something left over can also be factored. Factoring what's left. Okay? You should be able to at least identify each of these kinds of factoring, right? If we talk about doing factoring at a common factor, make sure you understand what we're talking about there. If somebody says you could factor it as a trinomial, you should recognize what that means. You should recognize the term difference of squares or perfect square trinomial. Again, factoring by grouping is not such a big deal, but